Session number one is a quick intro to agents, a little bit of research that's happening in this space. With real fun, it could be a hands-on workshop. We just don't talk or hear about agents, you can actually build them as we spoke. Okay, just a recap. We spoke about AI predicting, we spoke about AI assisting. The first workshop was building a lightweight assistant, using Party Rock in a simple way to get started. There's many more ways you can do it. But going into the world of fully collaborative AI, the idea is, for example, in the real world, is what if you could give every one of us a little person to help us all day? And I could use the help. Right? Like, hey, I don't want to do this job. Not your homework. You should do your homework. But I want to give some of my work to someone else, maybe some mundane task. Now, it's not just a little piece of software, but this one understands you, learns from you, never gets tired, and is taking care of what needs to be done from your day-to-day. So it knows what your next step may be and work on your behalf. Imagine not just one, imagine hundreds of these surrounding you and helping you and work. It's pretty amazing what agents can do when they're done right. We commissioned the research. We do a lot of research. Where Amazon produces roughly 800 peer-reviewed papers every year. 70% of them are in conjunction with universities. So we partner with a variety of universities. MIT is a big partner, as I mentioned before. Science Hub and mimo.mit.edu is how you can get more of the latest around our collaboration. But this one is an interesting paper where we said, hey, let's deploy a bunch of agents. And let's give a single agent a job, and let's give multiple agents the same job, with one agent taking care of one task, another agent taking care of another task, another agent taking care of another task, and watch how good multiple agents are compared to single agent. Almost sounds intuitive, right? When you have more specialists coming together to do something, you'd expect them to perform better. But this is the first time research was done that demonstrated both in physics environments, moral environments, that multiple agents do have an impact in how great work can get done. Which is interesting because now all of a sudden you can now organize your teams your agents into a little bit of teams. And each of those teams can be specialists or generalists. Remember we spoke about specialists and generalist models? Very similarly, you'll have specialists and generalist agents. And you bestow upon these agents, either you're a specialist or a generalist, by giving them a persona. If you remember the 4 building blocks, of an agent. So then we said, okay, now you're going to bring together a bunch of these agents. How do they communicate with each other? How do they collaborate with each other? How do they make decisions? Because remember, you're going to give them real world tasks. And you need to understand how these agents communicate, how do they make decisions. So these are 2 amazing papers again that came out that showed how collaboration can happen. The first one is how collaboration patterns can emerge among agents. And by the way, we are like weeks away from a variety of standards coming for inter-agent communication on how you can optimize that. A lot of open standards emerging on that. The second one is even more interesting. Even at this table, if I asked to make a decision, there's a lot of discussion that happens, right? There'll be a quorum, and at some point, a decision will emerge on a specific task. So when you take 5 humans and ask them to do a piece of work, it takes a little bit of time, and there are known techniques on how decision making happens in their life. The second paper really digs deep into how can a bunch of agents come towards a decision. Because remember, 95% of enterprise life is you making decisions, small, big, at various points in time. And if you're going to inject agents inside the enterprise, you need to understand how do they make decisions? How do you guide their decision-making abilities? So another really good paper that describes that. So we baked a lot of that into our own products, and we're seeing this more and more in a lot of startups, wherein you can assemble your agents, which now have infused personas and decision-making abilities, and now you can start giving them tasks. Like, hey, there's 200 claims sitting there. Take care of them. And all of a sudden, a bunch of agents will wake up. And they're like, oh, you want to do a job? Let me assemble myself. So in this case, in the factory environment, where one agent took the role of a supervisor. In fact, you'll be building a supervisor today. One will take the role of a process monitor, one the role of an inventory manager, one the role of an energy optimizer. You define these agents today. These are manually defined. So as of today, this is where you're the third wave of AI, where you're telling each AI what they are, giving them a persona, giving them access to a bunch of tools, and you basically build your team that way. And there's two ways in which we see these patterns pan out. Pattern number one is where you have a supervisor agent that just knows a bunch of specialists. When the request comes in, it doesn't do much. It's like, that looks like something that can be handled by that person, right? You always know someone in the team that just knows people. They just know how work gets done, right? So this is a very common pattern that's used, which is a routing style agentic workflow. The second one is a lot more sophisticated, wherein a request comes in and the supervisor agent applies a lot of reasoning, a lot of thinking, and says, how do I tackle this problem? What's the best way I can do this? And it uses two techniques. It uses two constraints. Constraint number one is a goal given to it. Hey, write me a marketing plan. Constraint number two is, here are the list of specialists available to me, their capabilities, the tools they have access to, and then go execute on these things. But it's no different. You're all going to be leaders. You're probably already leaders somewhere. As a leader, the biggest job you have is, how do I take a task? How do I dream up a task? Identify the right team I can assemble, and make sure that the work that's given to me is distributed across all of these folks so they come back with an outstanding result. That's pretty much what this is exactly. And today you'll be building one of these, today, right? One of these end-to-end environments. So you have routing agents and you have full-blown complex workflow orchestration, right? These are the two very common patterns. And there's a ton of examples of customers. These are all real customers we've been working with closely. Rocket rethought their customer experience completely, wherein if you call in, before it'd be a human taking a call, pulling up a whole bunch of systems, how do I troubleshoot it? All gone, right? Now the agents automatically know which system to go to, what work needs to get done. It's a series of AI agents that come in and to perform a task. Moody's, fairly well known in financial services. It's a very regulated industry, so it's very impressive for them to start embracing these. But they needed to create comprehensive financial reports. These are very laborious documents that need to get created, reading hundreds of documents and numbers and tables and et cetera, et cetera. So they've been using agents to scale out their document creation, process. And that's been pretty amazing to watch. Software development. I know it's going to be hard for you to see the screen, but this is inside one of our products called Q Developer. But I can go in, I just got introduced to a new code base. I just walk in, I'm like, I don't know what I'm looking at. And you just say, hey, /agent, tell me what's going on. And it'll come back and tell you, hey, here's what's happening in this code. These are like 4 agents wake up. They try to understand. I see Java, I see TypeScript, I see Python, I see Terraform. It distills the knowledge and produces all of that for you automatically. It'll also produce architecture diagrams for you, right, on the fly. But imagine walking into an environment in less than 5 minutes, you know everything about what's happening. Again, these are AI agents that are waking up. So you have agents in healthcare, agents in financial services, agents in customer care, agents in software development. They're going to be everywhere. In fact, they're going to be infused in every single part of our life. I see zero chance of walking into 2026 where any software project is not using an agent. Just simply not happening. If you heard of startups like Cursor, Codium, Devin, Cognition Labs, Q Developer, Copilot, blah, blah, I can go on and on and on and on. They all are starting to embrace agents more and more and more, right? So it's going to be every single place. So much so that 60% of the venture funding that came in. So for all of you that have venture capital or startup dreams, AI agents is where most of the funding is going right now. These are just some examples of agent-focused startups. There are agent-focused startups on verticals like financial services, healthcare, logistics, supply chain. There are startups that are focused on horizontal domains, could be sales, operations, security. But every single one of these startups wants to disrupt the industry. They want to disrupt the incumbent. They want to rethink enterprise workflows. So knowing agents is going to be extremely important, and all the underpinnings, that go behind it. And there's a wealth of resources you can go in. But if I go back to the architecture again, right? So I've been interleaving business and architecture today deliberately. But if you look at the architecture now, you have agents sitting at the top communicating with each other. The agents working through a combination of classic LLM models, deep reasoning models, combined with maybe custom models if you built them, right, for your domain. Of course, predictive models are not going anywhere, right? This is what a true modern, this new modern SaaS stack or a software application is going to look like. Any new startup is going to have some variables, right? To truly, if you want to distinguish yourself in the market, right? So almost every one of these startups really has something that looks like this. And there's some startups that have made so much headway. I'll call it one startup, Sierra right here, focus on customer care. So if you, start with Brett Taylor, who's a legend, I think Brett's next MIT, or Stanford, one of those two. If you buy a Sonos speaker, the minute you buy a Sonos speaker, you're assigned an onboarding agent, an AI agent that guides you through the process. Like, hey, are you okay? Now you may be getting emails and phone calls along the way, and you're like, oh, what a nice company. They keep track of me. Well, they are nice, but it's a series of AI agents that are doing that. And anytime you have a trouble, an agent wakes up and is like, hey, what kind of trouble are you having? So imagine an agent that is there for you. Even if you're not in the agent business, if you want to start, if you're in manufacturing, you design a product, but imagine assigning an AI agent that goes with your product everywhere, guiding your customers and maximizing its usage, right? So we're seeing some amazing examples, come out of all. As far as Amazon is concerned, our stack really maps to the architecture, right? So that stack that you saw on the left side, with agents and models and everything. So we have a series of products: Q, Bedrock, SageMaker. Bedrock is the one you'll use the most today. The team will introduce you to Bedrock. And Bedrock is where the models sit. Bedrock is where the agents sit. It's a model access machine. It's an agent orchestration machine. But you don't see a GPU. You don't just API in, API out. Right? Simple UI, simple-ish UIs. And that's where you'll be spending most of the time. If you like to build custom model, like you see a lot in domains, you end up using SageMaker. If you want to fine-tune these models or distill these models, you'll end up going to SageMaker. So those are the two popular ones. And then Q Business and Q Developer are two products think of PartyRock is very similar to Q Business. And Q Developer is used for software development, agents for software development, right? And then finally, while we use GPUs a lot, we built our own custom silicon, which has neural networks in the silicon level. Because matrix math, backpropagation, these are all mathematical techniques. Doing it in code is going to cause so much power consumption. But using custom silicon helps us lower the power requirements by 75 to 80%, and as a result, cost as well. There's two reasons why I share it. The future of AI is not going to be in GPUs. So that doesn't mean you short your NVIDIA stock. This is not financial guidance, right? But if you really want to step into the future, you need custom silicon to solve the problem. But more importantly, Amazon gives away custom silicon for students. So if you want to build a model, tune a model, use custom silicon, you have a program available. I'll make sure we get you the links. You can apply and get access to Amazon custom silicon so you can do cutting edge AI, but on our dime. So we'll give you credits and you can do whatever, right? But we believe that we need an AI in a powerful to that way. Okay, so with that, we'll go to the workshop. And you'll see a lot of Bedrock today. It's a lot of hands-on. We'll have a lot of questions, but the team put a lot of work to try to make it as easy as possible. But the team is here to actually, but hopefully that was good. Yeah. But ask questions, go on to it. Any questions as the team comes here and transitions? Yeah. Good.
Yeah, so earlier you showed results from a paper on one of the first slides on the agentic element, you showed results from a paper. And it said in a column, 0 shot. So does that mean it doesn't need even training data to do that task?
Correct. Yeah, 0 shot is basically that. So for example, the demo he showed with the LLM was 0 shot. The LLM was not pre-processed with any information. So like, here's the code and just do it, right? So it had instructions, but it didn't have any samples. So they're all 0 shot examples. which is pretty powerful, if you think about it. Yeah. Was that a question?
Yeah.
How does that work for healthcare data, especially in like diseases which is not well studied yet?
I think I mentioned this before. AI without data is meaningless. You need data. Now, interestingly, we are seeing more and more AI being applied to data. So I'm seeing a significant uptick in usage of generative AI models to clean, process, your existing data sets and create high quality synthetic data. Now, here's a dirty little secret. Every data available to build the next model is exhausted. Data doesn't exist anymore. So in fact, 100% of all the recent generation of models could be Llama 3.3, could be Claude 3.7, could be OpenAI, pick one of the models, right? GPT-4.5. Every one of them uses synthetic data. A significant chunk of their training is on synthetic data. So the cutting edge today is the best model that can create that synthetic data. Because if you don't have great data, you're not going to have a great model, right? So going back to the data question, you will use AI to clean your existing data, and you'll use AI to augment and create synthetic data. And then feed it back into another AI. Remember, it's all layers of AI. That's all it is. You'll feed it to the next AI so it can pick that clean plus new data to solve the next problem. So that's what's happening right now. Okay, ready? Any other questions?
Fascinating question. What happens is you have new natural data that's generated every year? How are those added on?
Sorry, new what?
How is like the natural data that is generated every year by humans added? Because we always talk about how like the data generated is every year, and then now we're seeing data limits are reached for these models. There will be natural data coming in. What are the processes of that?
Yeah, so yeah.
There's anything both synthetic and new natural data.
Yeah. So RAG is one technique by which you can dynamically add new data to an existing model. So RAG is a very common pattern. But what people end up doing is they have repeated cycles wherein they do incremental training on new data that comes in. So there's techniques on this called parameter efficient fine tuning is a broader bucket of terms. So let's say you build a neural network with 16 layers and a couple hundred million neurons, right? So you do that. But let's say now you have a little bit of more data that you want to build in. So what you basically do is, rather than retrain the whole model, you can essentially say, look, I want to modify, add a new layer or modify only specific things. So that's why it's called a parameter efficient way to fine tune or extend the model. There are also techniques called CPT, continued pre-training models as well, continued pre-training techniques. These are all known techniques to infuse new data that beyond RAG into existing models. And by the way, all these model providers are doing it because if you want to build a model from scratch, you're going to spend hundreds of millions of dollars. It's not practical. So every new model that comes in modifies only specific. There's a whole lore around how do you do that, and there's many techniques. So if you search for LoRa or QLoRa, low range adaptation, or quantized low range adaptation, these are all known techniques under PEF, the parameter efficient fine tuning, to extend existing models to new data.